Alright guys, we're back with another video. Today we're going to look at expanding and condensing logs using log rules. So first things first, have a guest helper today. I want you to watch this video on YouTube. I think if you click on it with the little hand tool on Notability, you can open up in Safari. There's going to be a link on Google Classroom also. But watch this video. It's 10 minutes. And yeah, he does a perfectly fine job.
So in dealing with logarithms, there are these
proving these three log rules. So take a look at that video, write down the notes for, write down the notes for the three proofs over here, here, and here. And in the proofs, he uses this fact, log base a of a to the x is equal to. So hopefully we all know that this is equal to x, right? Because this is saying what power of a is equal to a to the x, right? So the answer to that is x, right? Because a to the x equals a to the x. And also in the video, he does something which we haven't done before, but it should make sense. He takes the log of both sides of an equation, right? Let's just say that a is equal to b. Right, if a is equal to b, then we can also say, I don't know, 2a equals 2b. We can also say that the square root of a is equal to the square root of b. But we can also say log of a equals the log of b, right? You can take the log of both sides of an equation and it still has to be a true equation. So that's also in the video, right? Just think if you're taking the log of this value here, in order for it to be the same as the log of another value, right, a and b have to be equal. So it preserves equality. So just be aware of those two facts when you watch the video. And if you have any questions about what he does in the proofs, just let me know. But you're going to prove the, I guess you can call it like a log power rule. You can bring the n to the front of the log like that. That's equal to n times log base a of x. A multiplication log rule. In your argument, if you have the multiplication of multiple terms like so, right, it's actually the addition of the factors, like so. Kind of interesting. And division's really proven the same way as multiplication, right? When you're dividing, it's going to be subtraction. Right, it's kind of like your exponent rules, very similar, right? And that should make sense because they are inverses of another. All right, so just like for exponents, when you have a power to a power, right, that's addition. When you have, when you're dividing, I don't know, like 2 to the 5th over 2 squared, right, we're subtracting exponents. So that's something similar that's happening here, but just with logs. All right, so make sure those proofs make sense. These are going to be the three log properties or log rules that we're going to be looking at. All right, so if you haven't already, make sure you've paused the video and you've finished that first page. So we're going to be using these rules or properties to expand and condense log expressions. All right, so really today we're just practicing expanding and condensing logarithms because we're going to be using these properties when we solve log equations. All right, so number one here, we are going to expand this, which means we want to break it up into multiple pieces. So the first log rule says I can take this and I can move it to the front. Right, I'm using this first rule. So I can make this 2 times log base 12 of 3x. Right, now notice I have a product here in my argument. So I'm going to use the second rule. I'm going to make that the addition of the log of those two factors. So that's going to be 2 log base 12 of 3 plus log base 12 of x. But you got to be careful, right? It was times 2 to all of this, right? And so this should be in parentheses like so. And if you want to distribute the 2 now, we can say this is log base 12 of 3, or 2 times log base 12 of 3, plus 2 log base 12 of x. Right, and that's fully expanded. If you want, I guess you could move the 2 back, and you can do 3 squared. You can make that a 9. But I would consider that a condensing sort of process, so I would leave it with the multiplication in front when you're expanding. All right, and this was base 12. We haven't done anything with base 12. We haven't really done too much with logs, but this base, right, it could be any base. It wouldn't change the problem if that were any other number that's viable for logs. So if it were log base b, everything would just be log base b, and nothing else would change. So the base of a logarithm doesn't change the log rules or how you do any of these log problems, right? Just different bases, doesn't matter what it is. All right, number 2. Again, we're expanding. I notice a division in my argument, so I'm going to change that to subtraction of 2 logs. So I can make this log base 3 of 7x minus log base 3 of y squared. And now the 7x, that's the product. So I can write that as an addition. So that's log base 3 of 7 plus log base 3 of x. And then minus, well, I can move that exponent to the front, minus 2 log base 3 of y. And that's fully expanded. All right, number 3 down here. Again, exponent, I can shift that to the front. So 4, so we have ln here, right, the natural log. Remember that is just log base e. So it doesn't matter what the base is, that's not going to change anything, right? So don't write log base e, don't write ln. So we have the natural log of 5 divided by y cubed z. So again, division, we're going to make that subtraction. So 4 times, so all of this in parentheses, the natural log of 5 minus the natural log of y cubed z. In this argument over here, right, that's a product, so I can change that into addition. Make that 4 times the natural log of 5, minus the natural log of y cubed plus the natural log of z. So again, you have to be careful with parentheses. There's lots of nested parentheses. We are subtracting all of this, right? And all of that was equal to all of this. So the second thing I'm circling here also needs to be in parentheses, like so, right? Or you can just distribute the negative, doesn't matter. But at the end, after I distribute this 4 to all my terms and this negative to those 2 terms, we should be getting 4 natural log of 5 minus 4 ln of y cubed minus 4 ln of z. Right? Probably makes more sense to distribute this minus first and then the 4 to everything. And lastly, I notice a power here. I can move that to the front. That's going to change that to 4 times 3, right? Or 12. So my final answer is 4 ln 5 minus 12 ln of y minus 4 ln of z. All right, so that is expanded. So now we are going to go in reverse. Now I'm going to give you an expanded form and ask you to condense it and make it nice and neat like that. All right, so condensing. We're pretty much going to be looking at these rules, but going in reverse, going that way. So over here in the first example, I notice I have the addition of different logs, or in this case, the natural log. So when I have addition of different logs, I can change that to a product in the argument. So this is just natural log of, so natural log of 3 plus natural log of x is the natural log of 3x, right? Plus the natural log of y, which means it's the product of that, and so I can just make this natural log of 3xy. All right. Think about if you were to expand this, right? You can go back to that form as well. All right, number 2, it's subtraction, so it's division. Natural log of 5 over x. All right, that was pretty simple. And this last one. All right, so we're cleaning it up. So I'm going to take this coefficient and I'm going to make it an exponent. So that's log base 3 of x to the 1/4 power. All right, minus log base 3 of y minus log base 3 of z. So you have to be really careful when you're doing these. We gotta work from left to right, just like we would do with order of operations. So you can't really change these two into a fraction first. You have to work from left to right. I'm gonna make these two into a fraction first, right? I notice I have subtraction. That's my third rule, right? When I have subtraction, I can make it into a division of its argument like that. So they're all the same base, by the way. That's the reason why I can simplify these. I can make these first two terms log base 3 of x to the 1/4 divided by y. Right? And that is minus log base 3 of z. So I have another subtraction, so I can make this division again. So really, I can do x to the 1/4 over y divided by z. Right? That's what's that is what the argument is going to be. So when you have a fraction, you're dividing by a value like z here. We can change that to multiplication, like 1 over z. So I can really just add that z onto this existing denominator here and make the denominator yz. And this would be log base 3 of all of this. Cool? And so that is condensing logs. So that's really it for today. Pretty short lesson. All right, the majority of the lesson actually is in these proofs. So again, make sure you watch this video and that these 3 proofs make sense. All right, I can ask you something like this on an assessment. And of course, you can just watch the video again if you need to. But there you go. All right, so based on those examples up there, why don't you try these on your own? All right, so pause the video and have a go at these. So hopefully you tried them, and let's take a look. Bam. All right, there are my answers for each one. If you have any questions, let me know on these. All right, but this first one, I noticed it was division, right? So I made it this minus that, and then you have to break this up, right? That's log of y squared plus log of z. Product, we make it an addition. And make sure you distribute the minus sign, and you can bring that 1/3 to the front. All right. For this one, which we're condensing, all right, you cannot just bring the 2 over here and make this squared, right? That is not the rule. So if you look at the rule, you'll see that is not what is going on, right? The rule says when you have 2 in front of a single log, right, you can make that the exponent. So if you distribute that 2 first, right, then you can make it 2x squared, right, and then y squared. And then it's minus all of this. If you want, you can distribute the negative and just work left to right. Right, I chose to keep these 2 in a parentheses and combine them using multiplication. So first move that 2 as an exponent. So that's log of 5 squared, which is log of 25. And then it's log of 3 plus log of 25, which is log of 3 times 25, or log of 75. And then, just like before, we have a fraction minus this log. So we're going to do this fraction divided by 75. We're going to divide the arguments. And so you can just stick that 75 in the denominator to get that result. And I don't know why this is here. That's just a really easy one. So, all right. So that's going to be it. That is expanding and condensing logs. And I think we're going to have a test pretty soon. So that should be posted on Google Classroom. Make sure you watch out for that. And have a good weekend. I'll see you guys later.